Hello, everyone. My name is Helge Holzmann from the Internet Archive, and I'm going to talk about a new data processing and research platform today called Arch, and the 6 key features behind scalable and multi-tenant web archive processing with Arch. And these are the 6 key features you're going to hear in my talk. So, as we are a team of 7 authors, and not all of them fit on the title slide, I just copied the paper here. So this is the paper with all 7 authors and affiliations. All right. First of all, I'd like to start with my job at the archive and talk about the data processing. So I run the data processing in the web group at Internet Archive. And so that means basically I do everything after all the crawling, preservation, archiving, and instead I transform the data into something new or derive information or extract information from what's been archived. And for that, we use different technology. Usually we run our data processes on a pretty big computer cluster. So we have racks of multiple processing nodes. As you can see here, on top of that, there's Hadoop as the operating system of the cluster, so to speak. And on top of that, we usually use Spark as our driver for distributed data processing jobs. And the jobs are then written in Scala, along with a library that you can see here in the middle that's called Sparkling. And Sparkling is our data processing library that we use basically for all the data processing internally and now also open source, so any one of you can also use that. It's basically a toolbox tuned for efficiency with all the day-to-day web archiving and web data processing tools we use at the archive in order to create the data sets our partners request or are interested in. So now the question of this project basically was, how can we steal my job? And more specifically, the question was, how can we automate some of these processes at least? And the considerations here were, we kind of, if we want to automate these data generation and data transformation processes that I work on day to day, we kind of need predefined data access patterns. So we cannot just arbitrarily access any sort of data. Then there need to be kind of specifications and protocols. We need, of course, reserved computing capacity, so a separate cluster maybe, as well as a platform to control all these. And now the answer to that is exactly this paper. The outcome was basically 6 key principles or objectives a research platform with digital libraries and archives should meet. And these are the 6 ABCDEFs that I'm going to present now. So let's start with the A, and that is archive powered. So any research platform for archives or digital libraries, of course, should be backed by a digital library or an archive. That is basically the main data source that all the data comes from, but those are inherently not typically made for computations or not designed as a computational source. So these are usually the bottleneck, and in order to design the access more efficiently, you usually need additional layers on top of the archive. These should be distributed in a way, we'll see that later, but also seamless. So a user of such a platform doesn't care about all these details. They usually want to access the data that's in the archive and run some processes on them. Also, it should be big data ready. That means digital libraries or archives usually feature all these famous 3 big data Vs: volume, variety, and velocity. And web archives in particular do that, as they are completely unsorted and messy sources of all types of data that you can find on the internet. And in order to kind of facilitate access to those, we kind of need a pipeline like this, where we start with something big that's in the archive, and then scope it into collections, organize it more logically, filter it down, and then at some point, maybe sample, at some point derive a data set that is more easily manageable by users. Another crucial factor is concurrency. So that means concurrency on different levels. First of all, users should concurrently be able to access the system. So multiple users want to typically run jobs, but also a single job should be able to access data in multiple threads. And more particular, in a cluster environment, multiple nodes even should be able to access the same data. And here, as I mentioned in the beginning, the archive typically is the bottleneck. So we need some kind of, first of all, a central job manager to control all that with queues, schedulers, these kind of things. And we also need additional layers that manage the caching or a more direct access in a distributed way. And that brings me to distributed workflows. So basically everything in terms of data flows that we run in the archive are distributed. So they run on multiple machines, they run on multiple threads or multiple cores, anything of that. So we have typically a distributed cache as well, and we have something here in between where we preload our data sets. So whenever you want to access a data set from the archive, many of them, at least if you use our archived subscription service, those are already preloaded in a more distributed, more efficient way to access them. All the others are seamlessly, or should be seamlessly, reloaded and cached in a way. So if the server application here wants to access something that's not prepared to for efficient access, then they should seamlessly be reloaded into this distributed cache and made available to the user in a more efficient way. And same with storage. So if you save something and you would directly save it back to the archive, that would make another bottleneck. So you also want to organize the storage and the export of the data sets in a distributed way. And that should be supported by such a platform too. I've mentioned efficiency a lot. Most important here to mention again is the memory consumption usually. So if you deal with big amounts of data and you want to derive information from there, one important thing you should keep in mind is to not materialize anything. So we usually work on streams, and that also means all our data algorithms should run in parallel in some way. So ideally, the memory consumption should stay as low as possible. And last but not least, in order to make such a system future-proof, it should be flexible as much as possible. That is achieved here by an object-oriented architecture where we have different levels of jobs, and each job is kind of a specialization of another job. So a Spark job should be, for instance, a cluster job, and all these cluster jobs should be queued in the same queue so that we don't overfill the cluster, even though next time we run a Hadoop job or in the future, I don't know what technology will come up. And they should also be supported by this, all managed by the central job manager I've mentioned a couple of times already. So these are the 6 objectives we had, and with that, we came up with a platform that's called Arch, and Arch is basically a joint work of Archive.it, that's our web archiving subscription service. I'm sure many of you know about it, together with the people from Archives Unleashed. Archives Unleashed is probably also known by some of you already, that came out of university. It was an academic prototype project for exactly such a platform, and we now teamed up for the second phase of this project, got a new grant together, and on the left-hand side here, you can see the old Archives Unleashed Cloud. That was basically the first early prototype, and we turned that into something that is part of Archive.it, and later really made this from scratch a completely new platform with all these 6 key principles in mind. The focus on the development was pretty much completely on efficiency, while we made it all API first, so that you can run it or integrate it into different platforms. Here's an integration in Archive.it now. Yeah, and we had all these 6 key principles basically in mind all the time while building this. Just to give you an impression of the platform now, the look and feel is exactly like Archive.it. So if you are familiar with Archive.it, you will be easily familiar with this system too. It looks pretty much exactly the same. You get an overview of your collection here if you have an own web archive collection, and then you can run jobs down there. Those jobs are organized in 4 categories. We have collection jobs, network, text, and file formats. And for each of them, you can run a sample or full run. A full run means if your collection is in the petabytes, then a job would run pretty long, and that's why we split this up into sample and full, and we have separate queues in our scheduler for sample runs. So even though the full queue is full currently, you can still, to get an impression of what the job does or how the output looks, run a sample first. And there are currently 16 jobs integrated, all basically based on what I explained in the beginning, using Spark, using our sparking library, exactly what I usually do in my day-to-day work, just automated. As you can remember, that was the goal in the beginning. Here's a list of all the 16 jobs. And what may be particularly interesting for some of you is that we also integrated our 3 ARS jobs. Those are archived research services. Some of you may know those. They have been around for a long time. That is WAD for, which is a special format for extended metadata for web archives. WAIN for named entities. There's a typo, by the way. Sorry about that. And longitudinal graphs, LGA. And we already support those. Before, a partner always had to file a request. Then we generated those. I usually did. And now the system can do that in a pretty efficient way, even faster than before, and all integrated in here. And finally, all those results get visualized in the browser. We have different visualizations for different job types. There are bar charts for graphs. You can even play around with the graph, zoom in, zoom out, reorder them a little bit. You get data previews for all the data sets right in your browser, and you can download the data sets. Usually we, as I said, we store them in a distributed way, so on different nodes. But in order to download them, we pre-package them for the user so that you get a single file or 2 to 3 files. And for data sets like WAIN, where we have sometimes hundreds of files, we provide an API to download them in bulk. Yeah, just to give you some technical details in the end, I already mentioned this queuing system a lot. That is basically the core of Arch. So everything is based on this pretty advanced queuing system where you can also chain jobs. So for instance, many of our jobs have a Spark part in the beginning where the actual processing happens, and then a CLI part in the end to do some post-processing. And those are queued up one after the other. Everything is run in a Spark environment, in a shared Spark environment, but on a separate cluster. So there's free computing capacity for everyone using Arch. And you get direct access to the archive data. Before, in the original Archives Unleashed cloud thing, the collections had to be copied first to another system. That's not the case anymore. Everything is in the same infrastructure. Everything running in the Internet Archive network. And just to give you an outlook of what's going to happen next, we want to make our jobs more customizable so that you can actually configure. Right now, you can just start a job, and we have some parameters pre-configured, but we want to make that more free for users to define their own parameters for jobs like named entities, for instance, where you have many parameters that allow you to tune the job. We want to allow for user-defined queries. Also, publish datasets back into the archive to archive.org. So that's a plan for probably one of the next features, so that you can export your derivatives and make them available as an item in archive.org. And we want to add additional sources as well. And just as a little treat, and as part of the project in the beginning, that was actually one of our first deliverables of the project, is that we created 3 free datasets. So that these 3 datasets are publicly available. If you are interested, please take a look. They are on archive.org. There's an early web dataset, which features the early web from 1996 to 1999. And we generated language annotations for those all by ourselves and all freely available. So please take a look. There's a Friendster dataset, and there are multiple GeoCities datasets, actually based on the old GeoCities, if you remember Yahoo's GeoCities. Multiple derivations of that one. And that is it. Thank you for your attention. And there will be a live demo of the Arch system on Friday in the Weddell workshop. So if you're interested, please take a look. I think you can